All right. For our check your understanding for 3.1.1, we are in the spicy column. So let's get started. Again, we are trying to solve for equivalent fractions using the giant 1. Things that we know. We know that any number divided by itself is equal to 1, which shows up in the giant 1. We also know that we can write division as a fraction. So 5 divided by 5 can be written as 5 divided by 5, which shows up in this portion of our 1. And then the other thing that we know is any number times 1 is equal to itself. So it creates an equivalent amount, which shows up in multiplying by 1. So let's get started. We have 2/5 times 1 equals 6/15. So I'm going to ask myself 2 times what is equal to 6? And that is 3. And I know because this has to equal 1 that the bottom is also 3. And I can double check. 5 times 3 is equal to 15. Then down here we have 28/63 equals 1 times 4 somethings. This one is a little bit different because we have that equal sign in the front. Just a little different way to look at this type of problem. We still solve it the same way. We just are going to go this way. So I'm going to ask myself 4 times what is equal to 28? And I know that 4 times 7 is equal to 28. And the bottom would also be 7. Now, here's what I can do 2 different ways. I can say what times 7 is equal to 63, or I could ask myself 63 divided by 7 is equal to what? So 63 divided by 7 is 9, or 9 times 7 is equal to 63. Down here, same, we have the equal sign in front. So we're asking ourselves 12 times what is equal to 144? And we have 12. We know to equal 1, we also have to have 12 on the bottom. Now we're going to ask ourselves what times 12 is equal to 108? Or we could say 108 divided by 12 is equal to what? And 12 times 9 is equal to 108. All right. Now this one is the trickiest one of the bunch. So we have 40 25ths times 1 is equal to 8. You might look at that and say, oh, it is 5, because I know 5 times 8 is equal to 40. But when you actually do the problem, you have 40 times 5, which is not equal to 8. So the way that you want to look at this is you're going to ask yourself, how many times does 40 go into 8? So 8 divided by 40. I know that 40 cannot go into that 8 evenly, so I'm going to put my decimal and add a 0. That also means that my decimal needs to come up here. So 40 goes into 80 2 times, and I'm left with 0. 0.2. The 2 is in the tenths place, so I would go like that, and then I would simplify because they both can be divided by 2. So 2 divided by 2 is 1. 10 divided by 2 is 5. So it's actually 1/5. So you have a fraction within a fraction. So 1/5 of 1/5. So you would, again, multiply. You can multiply by 0.2. You could head this way, and I know that 5 times 5 is 25, but I would write it as 1/5. All right, let's take a look at the back side of our Check Your Understanding questions. The top part is for all levels. So we say, look at the two histograms below. So we have one histogram here, which is the Tigers, the name of the team. We have number of players and the height of the players. Then over here we have Panthers, which is another team name. Again, number of players and the height of players. They give you information about the heights of players on two basketball teams, the Tigers and the Panthers. Use the histograms to answer the following questions. The first question, which team has taller players? Which has shorter players? Explain your thinking. So if we take a look here, and I'm going to zoom in so we can see the graphs. The double line here is inches. And so we have 63 inches. So we have one player in between 63 and 66 inches. Looks like we have two players in between 69 and 72. In between 72 inches and 75 inches, we have 5. And then 75 and 78, we have 3. And then finally, our tallest player, 78 and 81 inches, we have 1. So it looks like we have a lot of players there in that kind of mid height on this scale. And then over here, in between 63 and 66, we have 1. 66 and 69, we have 3. 69 and 72, we have 1. 72 and 75, we have 2. 75 and 78, we have 3 again. And then 78 and 81, we have 2. So if we're looking at this, we can look at the players in a way that we can look at the, that biggest height here, which we have 2 and we have 1. And then if we look at this, we can compare. We have 3 and 3 here. And then this biggest, we have 5 here and only 2 here. So if we kind of break our grid in half, we would have 7 players on the biggest half here. But if you look, even though they only have one of the tallest players all together, they actually have 9 players on that side of the graph. So it really just depends on how you're looking at the graph in terms of who has the most players that are tall. And I think you can answer the question in multiple different ways. You can say that the Panthers have the tallest players because they have 2 players between 78 and 81 inches. Or you could say that the Tigers have the tallest players because they have 9 players that are the midway point and above. So it kind of really just depends on who or what part of the graph you want to focus on. So I'm just going to say that the Panthers have the 2 tallest players. And then, but the Tigers have the most players above 72 inches. And then if you look, same thing with the short players. Both teams have the shortest players, but if you look at that midway line, you have 5 here and only 3 here. So you could say both have an equal amount of short players or shortest player, and then the Panthers have the most shortest players. All right. Then over here, which team has heights that vary more? So when you have that word vary, you are going to, oops. Vary means different. So you want to look at the graphs that have the most players across or in each column. So if we look here, we have like 1, 2, 5, 3, 1, and we're missing an entire portion here. Here we have players in every single height category. So we would say that the Panthers have the most varying heights. Have the most heights. Oops, heights that vary. And then down here, which team has more players that are about the same height? We kind of look for which one has the most, and we have 5 players that are about the same height, and that's the most out of all of them. So we have Tigers have the most players about the same height. So that is how to read graphs. If you have questions, please let me know. All right, find the perimeter and area of the following shape. We have a triangle. This one is a little bit tricky. The perimeter we can find because we know that that is the area around a shape. The area is the space inside the shape. So the perimeter we know because we can add up these numbers. So perimeter is equal to 7.25 plus 7.2 plus 8. So we have 7, 14, 22.45 centimeters is our perimeter. Now, area. This is tricky, and if you didn't get it, that's fine. We are not going to get into this for a while. But when you are finding the area of a triangle, the area of a triangle is actually your height times your length divided by 2. But the problem that we run into here is we don't have the height. We don't know how tall our our triangle is. So what we have to use is something called Heron's formula. And it is really just fancy talk for the square root of S minus SA, which would be side A. So I'm just going to label that side A, multiplied by S minus side B, which I'm just going to label that side B, multiplied by S minus side C, and I'm going to label that as side C. What we need to figure out is S, which stands for semi-perimeter. So to find the semi-perimeter is we would take our perimeter and divide it by 2. So we have 22.45 divided by 2, which would be equal to 11.2 0.225. So now we're going to get into this, and it's going to be a big problem. We're going to say area is the square root of 11.225 multiplied by 11.225 minus A, which is 7.2, multiplied by S, which is 11.225, minus B, which is 8, multiplied by 11.225 minus C, which is 7.25. Long equation. See what I'm saying about it being kind of like a trick question because we haven't really gone over this. So if you're sticking with me, excellent job. And I'm actually going to get a sticky note so that you can see how we solve this. So we're going to start here with A is the square root, and we're going to take that 11.225, and we're going to be multiplying it by some numbers. So we have 11.225 minus 7.2, which is equal to 4.025. And then we're multiplying that by that 11.225 minus 8, which gives us 3.225. And then finally, our last one is that 11.225 minus our last side, which is 7.25, which gives us 3.975. All right, then we would just go through and multiply all of these together, which actually I'm going to use a calculator for. So we have 11.225 times 4.025 times 3.225 times 3.975. Oh my goodness. Now that's a number. And that is equal to 579.1873 ... And we would need the square root of that. Which would be about, looks like 24.066 ... So there's the answer. I know that was a lot, but good for you for trying if you did. All right, let's move on to this bottom one. Use the distributive property to rewrite each of the expressions below, then simplify. Simplify is just fancy for solve. So first step is we want to decompose this number on the inside by breaking it into place values. So we have 2,000 plus 500 plus, we have nothing in the tens, and so 2. And then we would distribute that 12 to each of the numbers in my parentheses. So we'd have 12 times 2,000 plus, we bring that plus down, 12 times 500 plus 12 times 2. Then here, 12 times 2 is 24, and then I bring down my 3 zeros, plus 12 times 5 is equal to 60, and then I bring down my 2 zeros, plus 12 times 2 is 24. Now, if solving this way does not work out, you can go vertically and line up the place values, which is how I like to solve, just because it is easier for me to see where each of those numbers goes. All right, so our answer is 30,024.